I remember clearly a chemistry teacher saying, "Oh, I hate teaching this part about significant figures because I work so hard in teaching them these 7 rules, and then I give them a quiz and they mess up on it, almost like I didn't teach anything." And at first, I taught like they did because I was a new chemistry teacher. That was about 35 years ago, but so I taught like they did. And then I figured out, after that first year, I figured out, number one, why people were not being successful with this part of that chapter. And I'm going to teach a little differently than you'll see other teachers do it, I think. Okay? So first of all, I want to show you, does anybody know what significant figures are? Anybody know that? It's kind of a weird number, isn't it? It's kind of a weird thing, isn't it? Well, this chapter is on measurement, so I'm going to show you something here. I'm going to measure something. Okay, does everybody see that line? I'm going to measure that line. And in science, there's a lot of measurement. And so what I'm going to show you is a set of rules that you'll never hear your math teacher talk about. Everybody get this? You're not even going to like some of the things I say today. One of the things I'll say is, when is 5 centimeters not necessarily 5 centimeters? I promise you in your math class, 5 centimeters is always 5 centimeters. Because what kind of numbers do they use in math class? I bet your teachers never ask you this. They're called theoretical numbers. The number 5 in math class has no error. It's 5.000 to infinity. To infinity. It's the theoretical number 5. There's no error. But what happens in science when I measure something? All measurements have 3 things in common with each other. Every measurement in the world has a number to it. What else does it have to it? It has a number. What else? If you measure something, it's going to have a number. Help me out. Matthew, you look like you're thinking about it. Not really. Every measurement has a number. What else? Think about a measurement. 10 gallons of gas. A what now? A unit. That's called a unit, okay? It has a number, it has a unit, and it has something else, error. Every measured number has error. Now, that's not going to happen in math class because they don't use measured numbers. But if you're a scientist or an engineer, you have to understand you work in the world of measured numbers. So let me measure this number for you, okay? Now, this ruler I have is not great. It's not a great ruler. Matter of fact, it only has that many lines on the whole ruler. It's not great. Oh well, that's all I have. Let's measure. Every scientist in the world and every engineer knows that when you measure something, you are to include every number that you're certain about because you have lines to make you certain. And then you have to guess one number where you don't have lines. And these are called significant figures. So if I gave this line to somebody in Russia, an engineer, and I said, use this ruler and measure it, here's what they would do. They'd say, well, one of these, but not 2. I am certain that it's one of those, but not 2. But I also know it's more than 1, isn't it? So what do I do with this empty space? What do I do with this empty space here? What do I divide that into? My mind has to divide the empty space into how many pieces? Take a wild guess. What? That's something they might do in America. What would I divide the empty space into? Who said it? Somebody said it. How many? What? Say it again. No, that's America. What?
7.
That's America. 10. Powers of 10. See that? The whole metric system is based on powers of 10, isn't it? So what you do is you divide this empty space into 10 pieces. So what if you thought it was halfway? What if you thought it was halfway across? What would you say? You'd say 1.5, wouldn't you? But it's not halfway, so what are you going to think? What do you think here? Yeah. I don't know. Does some of you think that maybe? Anybody think something else? Now, you're not allowed to say 1.25. You're not allowed. Because these rules that I'm telling you now, every scientist and every engineer uses the same rules. If you're in the world of measured numbers, you have to put every one number you're certain about plus one guess, one. Now, I have to put a unit here. Does anybody know what this is called? How much that is? I'll give you a clue. This is a meter. Okay, this is a meter, whole thing. This is 1/10 of that stick. What's this called? What would you call a tenth of a meter? Now, I know it's kind of like Monday morning, but it's actually Tuesday, right? What do you call a tenth of a meter? Decimeter. Decimeter's like that. Everybody has a decimeter, right? Everybody has a decimeter. Okay, so anyway, I'm going to put the unit here. Now, does that measurement have a number to it? Yes. Does it have a unit? Yes. And does it have error? Yes. Would you bet $100 that it was 1.2? And if it was 1.19, you'd lose your $100. Would you bet $100? No. That's why you're uncertain there, but you have to put one uncertain number. Now, let me use another ruler. Now, look, why is this ruler better? What makes this ruler better? What do you think? J3, why is this ruler better? It has more marks, doesn't it? All right, let's try it. Okay, there's 10, 11, 12. Is that a little bit past that line? Oh, wait, let me line this up. Ooh, it's just barely. Okay, so what do you think? Is it 12? Is everybody certain that it would be 12 and not 13 or not? Are you certain about 12 and not 13 or not? What do you think? Or is it 13? I'm sorry, did I say 12? Is everybody certain it's 13, not 14? Okay, now, if you're certain about that, you're forced to put one more number, aren't you? You're forced to put one more number. Can I? I'm gonna play a little game with you a little bit here. I'm gonna make this a little bit bigger so you don't. I don't want to mess with your mind a little bit. All right, what about that? So we have 13, and here's 14, isn't it? Now, do you think it's 13.5? 13.4? 13.3? 13.2? 13.1? Okay. I would be all right if you said 13.1. I'd be all right. And these are called centimeters. Everybody knows what a centimeter is, right? Little finger right here. Okay. What's different? I measured the same line. Why am I getting different numbers? Yes. And that's why some people, I think, didn't like it when I used to teach it. Why did kids hate it? I don't think they knew where it came from. Where do significant numbers come from? They come from the instrument you choose to use. You get that? Now, I'm going to do it one more time. And I'm going to do this as well as I can. I'll magnify the thing. Okay, are you ready? Here we go. Watch what happens here. Okay, can you see that? All right, what do you think? Aiden, give me a hit on this. Are you certain that it's 13? Are you certain that it's 13.1? Or could it be 13.2? 13.1? Maybe a little bit more than that? All right, take that little tiny piece and divide it into 10 sections. What do you think it is? 13.1? 13.1? Okay. All right. All right, so what's our lesson then? What's the lesson? That in a world of measured numbers, we have to have a set of rules that tell everybody in the world what's going on here. Like, if I told you somebody in Germany, and I told them the line was this long, and they knew about significant figures, you know what they would know in their mind? Oh, I know what your ruler look like. Your ruler look like this. Your ruler looked like this, and you had these lines here, and that it was a bad ruler. I know this ruler is not very good because you know when you guessed? When did you start guessing? 10th place, didn't it? So I know you had a ruler had ones on it, but you didn't have any other lines, and that's what they're telling them. Even if you aren't here, I'm letting you know what my ruler looks like. And what about this one? What's that mean? Oh, I had lines for 10s. I had lines for 1s. I even had lines for 10th place. You didn't have to guess on this ruler till you got to hundreds. So if you ever use this ruler right here and you don't go to hundreds place, then you didn't learn the lesson. Got that? You have to go to hundreds place. So now what's interesting, here's what's interesting about this world that's different than math world. Go to this page right here. Oops, this one's already marked on. Darn it. Let me see if I can find one not marked on. I happen to pick the two that are marked on. This one should not be marked on. All right. We'll go around the room, and I think we'll start back in the back with Ben. And we'll go around the room, and there's A, B, C, D, E, F. We'll just keep going around the room. And Gabe, you'll be second. Okay, ready? Now, what I want you to do is to, let me put this up here. Now, Ben, you have to be first, so you have the hard part. You have to be number one. Tell me, what will you think A, find the letter A, and tell me what you would write down for this one. These are in centimeters. Okay. All right, 12.5 centimeters. Is that right? What do you think about that? Okay, let's pretend that that Ben writes this measurement down, sends it to somebody in New Zealand, and he's an engineer. The engineer in New Zealand sees 12.5 centimeters. What does he think automatically? What does your ruler look like? He says, I know you had lines for 10s, and I had lines for 1s, but Ben, you're telling me you did not have lines for 10th place? Because you guessed 10th place, didn't you? You did not have lines for 10th place? And that would be a lie, wouldn't it? You did have lines for 10th place. So this is something you'll never do in math class, but Ben, you have to fix this because you're lying to people if you say 12.5.
12.50.
Yes. Yes. And you know what? If you went up to your math teacher and you said 12.5 and 12.50, what would every math teacher tell you? It's the same thing. That's what they would say. Get that? But in a world of measured number, it's not the same. It's not the same. Now, by the way, if I had to put this in a calculator, would I put 12.50? No. The calculator doesn't know anything about measured numbers. You get it? I still put 12.5 in a calculator, but if I had to write it down, I had to put 12.50 because that's the kind of ruler you have. How many of you, look at A, how many of you thought it wasn't quite 12.5? Did anybody think it wasn't quite there? Yes. What did you say?
Like 12.49.
Yes. See? And I would have taken both of those answers. I would not have taken 12.5 because it tells me you don't understand the lesson. But 12.49, so hey Ben, if Matthew would have said he would have gone to 100th place, that means you would have had to go to 100th place too, isn't that right? Now I'm looking at your faces because you don't like some of this because you'll never hear this in math class, will you? But if you do stay in science or you go into any kind of engineering, you'll understand what this is all about. All right, Gabe, you're doing B. 11 point what? 3. Ah, look at that. He learned something there. Did anybody have something different? Yes. Yeah. Did anybody have something different on that one? Okay. Let's do C.
I got 13.21.
13 point what?
21.
Okay, let's take a look. Now, I think, this is my opinion, What's halfway, Sean, what's halfway between this line and that line? 13.5, right? This is getting kind of close to halfway, isn't it? So I don't think I'm going to say 13.21. That 13.21 would be really, really close to this line. So let me try that again. I don't think that's close enough for me. I don't think it's halfway. What do you think?
13.25.
All right, so if you think it's halfway, I'm okay with that. Did anybody think it was 13.24? I like that one too. I would have taken both those. You get that? I would not have taken 13.1. I think that's too close. All right, Thomas, you're doing D. D dog.
I got like 13.95
Okay, hang on.
or
13.9. Okay, did anybody put 13.94? I like that one too. I like both of those. You get it? And don't I understand that this you had to guess, didn't it? Everybody in the world knows you had to guess that last number. All right, E is Makeda. Say it again.
10.301.
Okay, so 10.30. Did anybody have something else? Okay, or 10 point what? 29. I like both of those. Okay, next. Taylor, you're doing F.
11.98.
Okay, 11.9. Woo! Man, that's close. Did anybody think it was 12.00? Okay. Did anybody think it was 11.99? How many people said 11.98? I would say 9.8. 9.9. It's pretty close to that line. I think it's really close. I would tend to think I would take both of these answers here. 11.98 is not unreasonable. I just don't think it's quite there to say 0.9 for the last number, 0.99. How about G, J3? And this little line means just 5. That means it's 5. So 9.5, 9.6. Go ahead. 9.6 what? Do you think it's halfway or not? Do you think it's more than halfway? Yeah, if it was halfway, you'd say 5. What do you think? More than halfway? What are you going to say? 6? Okay, anybody say 9.67? Okay, I'll take both those. I like that. All right, H. All right.
I had 12.92.
12 point what? 9?
2.
3? Did anybody have 12.92? 12.94? Okay, I like both those. Okay, and let's go I. We're going to I. All right, Matthew.
Said 14.31.
All right, 3-1. Anybody think it's 14.30? What now? Okay. And J, last one.
11.7.
Wait a minute, where am I at? Oh, J, here it is. 11 point, say it again.
70.
Oh, 70, okay. Did anybody think it was 11.69? All right. All right, wait. Do you at least understand that this thing called significant figures has to do with measured numbers, all right? So you'll never hear about this in math class because their number has no error. Okay, thank you very much. I think tomorrow, I will see you tomorrow, but you'll have the PSAT in the morning, won't you? Okay.